Okay, my name is Matthew Farwell. I'm here to present the Scalatest Selenium DSL. It's weird having the voice heard like that. Never mind. Okay, just a little bit about me, because I'm up here and you're down there and you have to listen to me, is I have 20 years development experience, project lead on Scala style, which is style checker for Scala, which undoubtedly you all use. Contributed to various open source projects, notably Scalatest, JUnit. Co-author with Josh on SBT in action. But the most important point on the slide here is at the bottom is the GitHub project if you want to sing along with the examples that we're going to do today. So the goals here are to present the Selenium DSL, which was written by Bill and Jay. Show how it simplifies the writing of Selenium tests. At least I think it simplifies the writing of Selenium tests. You'll find out what I think about it in a minute. Show how it can be used to test a JavaScript-heavy application. We have a JavaScript-heavy application to show you, so that's good. Show how it can be used to make more useful tests or more extensive tests, because we don't just test at Nextthink, where I work. We don't just test HTML and websites. We test other things as well. And we'll finish off with a thing about the future. Okay, so does everyone know what Selenium is? Anybody not know what Selenium is? Okay, Selenium it automates browsers. So there is a driver in a jar somewhere that fires up a Firefox, fires up a Chrome, something like that, and tells it what to do. Click on this button, click on this thing, do this thing, go away, that sort of thing. It works with Firefox, Chrome, Internet Explorer, and various other browsers. And has interfaces for Java, Python, Ruby. So the Selenium DSL for Scalatest obviously uses as its base the Java one. We'll be looking at it from the point of view of testing, but actually you could use it for other stuff. So for instance, if you have an administration task that you need to perform on 20 different web servers, you could do it through a browser, something like that. Okay, so quick example. This is the Java version. Now, I find this easy to read. Do you? No. But basically what we're doing is we are saying that we're firing up a new Firefox driver. We are going to google.ch. We're finding an element by the name of Q, and we're putting Matthew Farwell into Q there. We're finding a button. Well, actually, we're finding an element which is called button G. We're clicking on it. Sorry. We're clicking on it. And then we're waiting until this element here, result stats, appears. And then we're coming out of this loop. This wait is a loop. Basically, it's waiting for 30 seconds here. And then, finally, we're looking at the tag body, and we're checking that it contains farwell.co.uk. And on that basis, it's deciding whether or not we're famous enough. Okay, now, this is absolutely brilliant compared to what you would have to do to actually automate a normal browser. We can improve it, but the main thing for me here that I want you to pick up is the problem with the wait here. For me, this is a major problem. I'll explain why in a minute. It's not doing enough. So let's just quickly have a look at the Python example. Now, Python is quite a lot more concise than the Java, but it's still not quite good enough. It's doing approximately the same thing. There's no loop here, but it's just an example. Okay. So let's have a quick look at the Scala example, using this DSL. So as you can see, that's a lot better. But we don't want to allow you to look at that for too long, because otherwise you wouldn't listen to the rest of the talk. Okay, so this is our application that we're going to test. There we go. Now, as you can see, oh, no, we can't see because it hasn't switched. Hang on a minute. Yay. Okay, so as you can see, it's actually quite a... It's not a sophisticated application, but there's a table of users. You can forward through the list. You can change the size of the list, etc., etc., etc. You can do filtering. There you go. You can do filtering. This is AngularJS, by the way. It's a fantastic thing, is AngularJS. It's annoying, however, that you can't see the buttons here. So you can actually click on the buttons here. You can edit the users. You can go back to the users list, etc., etc., etc. Now, the problem with this, for my demonstration purposes, is it is too fast. So what I'm going to do something nasty, and I'm going to insert into our code a wait. So basically between every call that we make, it will now wait between 2 and 3 seconds. So we shall see what that looks like now. And you can see the problem. Has anybody used Selenium for testing before? You'll have come across this problem. It gets even worse when you have a JavaScript-heavy application. So I'll just explain what's happening, and then I'll explain, then you'll see it more clearly. Basically, the page loads, the HTML loads, then there's an AJAX call to the server, and it fills in the data afterwards. Okay, so let me just refresh again. You'll see what I mean. Damn. Now, I've inserted this wait of 2 or 3 seconds. But anybody who's had experience with Selenium will know that there is a problem here. The problem is it works fine on the developer's PC, but it does not work on the Jenkins server. So in the Java case, what you end up doing is you end up, just before this wait here, you say thread.sleep 2000. It's exactly that, unfortunately. So how do we fix this? Well, we'll come on to that, because I've got this slide first. I forgot about this slide. So this is one of our actual tests. Okay, this is testing that. Hopefully you'll be able to read this, and that's the point about this, is that first we go to the URL, which is localhost 9100. Then we're saying that the current URL should now be base URL admin index HTML/users. So when the page is reloaded, that means that you get, basically it does a redirect. Okay, so we're testing that we're redirecting. We're checking that the thing that we have called page title, so we do a find on page title. Page title is either an ID, so it searches for an ID, and then it searches for a name. Okay, so if we go back to our original Java one, okay, you can see here, we always have to specify either name or ID, okay? But by default, the DSL, you don't have to specify either. You can specify one or the other, but you don't have to. Then we're testing, the find, we're making sure that the text in that element is users. Then we're doing a find on a text field. We're making sure that should be empty. And then we're clicking on one of our IDs, which, of course, we've put in because we're good developers. And we're making sure that the value in here which is, let's have a quick look. That's not very good, is it? It's hard working on a small screen. So there you go. So we got a thing called user username 2. Okay, so there you go, user username 2. And we're making sure that the thing that's in there is Matthew. Okay, so that is our basic test. That is our first test. And as you can see, it's quite concise. And some of you will have noticed that find, it returns an option. And I'm doing something naughty there. I'm doing a .get. Now, there's a specific reason I'm doing a .get directly on a find rather than going through a flat map or something like that. And I will explain it now. Now, the problem is that has a bug. That will fall into the problem that we had before. So let's just have a go. Dum-dum-dee-dum. So if we go to user spec 1, we can do Control F11. And we should run the test. Oh, this is annoying. Hold on a minute, sorry. What I have to do, I have to duplicate these displays. So this time, when I run it, you might actually get to look at Firefox this time. Yay, it's fallen over. So actually, the most irritating thing with this is that sometimes it falls over, and sometimes it doesn't. So why have you just done that? Oh, it's running the wrong one. Just talk amongst yourselves while. So it's falling over. And the reason for that is, as I said before, what we need to do is that it's refreshing the page, and then at the end, it's doing the test before the actual data has been filled in the test. So Scalatest has a facility for this. It's not specific to the Selenium DSL. It's called Eventually. Now, what this does, it is absolutely fantastic. I really, really, really like Eventually, is that it tries for a certain length of time. By default, it's half a second. But in our tests, we've set it to 15 seconds, which means that if there is an exception in there, i.e. the test has failed, or it can't find an element, or its find.get is a none, for instance, so there's no element on the page, it will retry. Which means that, fantastically, all you have to do to fix a timing problem in your test, generally, is to put an eventually around it. And that's it. There is another subtle problem here, in that what you can do, let's imagine that our text field there, for the user search, I'll show you the text field again. Okay, this search field is filled in with data as well. So it is filled in with data that is taken from the database. In that case, what you can do, what you need to do, where's it gone? That one, is you can actually put all of it into an eventually. And it will repeat everything that's in that inner loop every time until the 15 seconds are up. So it literally is. Our instinct now, when we're doing Selenium tests, is if there's a timing problem, we put an eventually loop around it. And most of the time, 99% of the time, it goes away. I love eventually. I really do. It's fantastic. Yep, sorry.
Seems to me that there is a drawback in doing that.
Yep.
In order to get a real failure, you always have to wait 15 seconds.
Yes. Sorry, the question was to get a real failure. So if it's a failure that, so for instance, the page will never have a username to, you will have to wait 15 seconds for it to work, for it to tell you that. Yes, that is a drawback. But it's my experience that I'm willing to wait for that 15 seconds to stop the overnight builds in Jenkins from falling over to...
I'm just wondering if it could be the solution with futures and async blocks. That would solve the same problem where you don't have the results as they arrive.
That's what eventually does. It doesn't... It depends what you're testing. The suggestion is that we use future and async blocks, but it depends what you're testing, because if the thing is never going to be there, then you're going to have a timeout of some description on the future. The problem is that you have a block which may or may not be there. So you're still going to have to wait for the timeout anyway. Okay. So what you can do is you can add eventually to the entire block. And if we go to here, we can see that. Usually it will work. Hopefully it will work. And you can see here that as soon as the data gets filled in, pretty much, it works. So all tests pass. Yay! This is great. Where's it gone? There it is. Okay, so how do you get and set values? We've already seen a little bit of this. And you can start to see how useful eventually is here. Okay, so you go to our URL. You click on something called user edit to, which happens to be a button, which happens to be on the screen. Okay, so between that and the click, it's doing a refresh of the page. It's waiting for the data to become available. If it's never available, it's never available. Okay, then that will do a refresh of the page as well. It'll do a reload of the page over a different URL. We're looking for a text field called user full name. The value should be whatever. It should be enabled. And then finally, we're setting the value to that text field to be Matthew Farwell is great, which should make the database fall over. And then for the second part of our test, we're saying that there is a password field, which we're setting the value to be hello field. There's another password field called confirm password. We're setting the value to be hello world. Then we're testing that an error box appears where the text should be passwords do not match. Okay? Anybody spot any problems with that? The passwords do match. It's amazing. Which brings us on to a little problem. The problem is... Hello? The problem is that how do you know that that's not worked? How do you debug this? Now, there are a few options. All of the things that are provided by the Selenium DSL are actually available in Selenium itself, but they're harder to get at. Let's put it like that. So here, what you can do is you can say capture to foo.ping, and if your driver supports a screenshot, then it will take a screenshot. You also have access to things like the current URL. You've obviously got access to all of the elements on the page. You've got access to the page source. There's a block called with screenshot, which basically means if you throw an exception inside, it's not quite an exception, but pretty much, then it will take a screenshot at that point. This is brilliant, but it means you have to insert in a particular place in the test that you want to know about capture. So a better pattern that we have is to use the inbuilt Scalatest reporters, and in the case where you have a test failed, we do a capture. So actually, did I run this test yet? Yes, I did. Oh, then we got one. I've got one that fell over. Hang on a minute. Let's run this test. So we run our test. Oh, it's just reset. I'm sorry, PowerPoint is annoying. PowerPoint has reset my pages so that they're no longer duplicated. Please don't do that, PowerPoint. Okay, so let's do that again. So we'll run our test. Firefox appears, waits, does some more waiting. There you go. So our test has fallen over. Now, in this case, the message is actually there. It says the message that we were expecting is not passwords do not match, but that's not always the case. So actually, we can see we have a screenshot of what was happening at that particular time. This we found very useful. We've even got the HTML there that I've put out. So that's the HTML of the page at the time. You can do a full dump if you want. Oops, sorry. Cool. So what other input types does the Selenium DSL support? The thing about the input types is these are, if it's searching for a text field, then it'll look for something which is the text field. If it's searching for password field, so look for an input type of type equals password. A button, it will expect to submit, this sort of thing. Okay, so these are all type safe as soon as these come in. So if you look for an element which isn't a radio button on a page, it will throw an exception at that point, throw a test error, test failed. Anybody at Bill's talk earlier on today? Yeah, it was me that introduced that bug when I added the HTML5 stuff. So sorry about that, Bill. You can not only do lookups based on IDs, but you can do lookups based on other stuff. So here, we are testing that. Well, this is a serious question. Does anybody know what we're testing there? Can anybody tell me what we're testing there? So here we have our table. We have 10 items in that table, and we want to make sure that every time the first time we display this table, it always defaults to 10. So we have here options of 30, 50, and all, and we want to make sure that always 10 always has 10. Where's it gone? There it is. So the reason we're doing that how we're doing that, is we're searching for TDs with an ID of username, which starts with a username, and we're counting all of the TRs that are associated with those TDs. Now it's a bit, how can I put this? It's quite fragile, this sort of testing with the XPATH, but if that's all you've got, that's all you've got. There are a number of patterns that are recommended in DSL. So one of the things you can do is you can actually have a particular object which extends page, and then you can parameterize each particular page. We tend to use strings, but some people use that. You can add and remove cookies. You can switch between windows, between frames, between switch. So if you have a pop-up alert, you can switch to that, and you can click on the OK on the alert, etc., etc., etc. You can move backwards and forwards. You can execute arbitrary JavaScript on a particular in the context of a particular page. So for instance, the second line there, we're returning document.title, so it will return you the title for that document. Okay. So that is basically a very quick introduction to the DSL. Now we're going to move on to how we use it, that next thing, to help us to test. And it's in the context of a particular type of problem. The type of problem that we have, which I'll illustrate here with our application, is we are going to add a user to our database. Now, the question is, we can write all of these tests. We can in Selenium, okay? But how do we test that the user has been added? Now, one thing we could do, this is not excluded, is check that this total here, 132, becomes 133. We could check that, say, we do a search and make sure that there's nothing in that list. But actually, what would probably be better, and it depends on, obviously depends on your context, and I'll explain about our context, is what a lot of the time we don't really care about the front end. We don't really care about what the front end displays. We have a thing called here, this is a thing called the orchestrator. Now the orchestrator, it has an XML API, it has an HTML server over here, which actually attacks the XML API, but hey, the purpose of the orchestrator is to produce appliances here on which we run services. Okay, so the orchestrator can create new services on these appliances. The orchestrator has a database here, and it has two sets of linked servers at the top, both with their own databases and their own XML APIs. So this means that basically clicking on a button here can have an impact here in the database on those servers up there through the XML APIs of those servers up there and on those databases up there. So it's not particularly useful to be able to say, has something changed on a front-end page? And so we need to extend what we're doing to make sure that all of these things are taken into account. So we use Scalatest for this, and a part of that Scalatest is this Selenium DSL to drive the HTML front end. So in our context, for our example, what we're doing is we have a thing called services, which I won't define, I'll let you define it for yourselves, which basically calls a REST API to make sure that the list of users we've added a user to the list. And this is all fairly simple stuff. But you can see that, again, we're wrapping it in eventually. And actually, this is what you want it to do as well. So all of our tests that we do for this system as well are obviously asynchronous. So they're all pretty much wrapped in the same sort of logic where we have to do an eventually, except the eventually is quite long. It's in the minutes sometimes. Okay, there's one more pattern that I want to show you. And that is basically how to do multi-browser testing. Now, the pattern that works quite well for us is to have basically an abstract base class which contains our tests. So let's have a look at our tests here. Okay. So you can see here we have an abstract base class with our tests, which is basically just the first test again duplicated. And then go back to SBT. We can run a particular. So what we do is we use JUnit categories. Wrong one, sorry. All right, what we do is on our Jenkins boxes, we run JUnit categories to make sure that only a certain set of tests is run. So that's our Firefox test. And then we can do Chrome. Yay. Hello, Chrome. And obviously, you can do the same with Internet Explorer, Safari, whatever you want, really. Does anybody have any questions so far? Yes. I can't remember the syntax exactly, but in our, there are two ways. Basically, you can see here we have a trait which all of our tests extend. It's called the cake pattern. But here we have integration patience. Now, integration patience, basically, you can see there's a default patience configuration, which is 15 seconds, and it does every 150 milliseconds. So I think, Bill will correct me if he's still here, that, yes, can you specify it as a parameter to the actual eventually? Okay, you can. Or you can have a particular patient setting for a particular test. We have a particular patient setting for a particular test. Sorry, go on. Yeah. We tend to put it into, okay, so we tend to take the view that, okay, if we're checking two services, we'll just do the first service and then the second service. Because we need to, we don't care if one fails and two fail. So we don't tend to stack things like that. Any other questions? Okay. So the context that we have at next thing, which is we have a lot of code which is partially tested with Selenium and Java and Python. We have lots of new code which we've written, which has been tested with Scalatest Selenium DSL. So basically we can compare the two, and like I said, a simple click on a page can have an impact way beyond the fact that something has changed in a database somewhere. And we use Selenium to test pure HTML, GWT, AngularJS applications. GWT and AngularJS are slightly different things, but they have the same sort of problems that are associated. This is our experience. So the DSL is very good for walking through a test with somebody. So if we were to show that to somebody who's, let's say, semi-technical, it's actually quite easy to explain what a test is doing. We're clicking on this button, we're finding this value, etc., etc., etc. We have tests written by developers in quotes and testers in quotes. Our team is made up of basically developers and QA people. The QA people are technical QA people, so they can write their Scala tests. We write so the developers initialize the Scala tests for the Selenium. The QA people add to them, but they continue to be maintained by the developers. So they're actually quite easy to, what I'm trying to say is they're easy to be maintained by non-developer people, which is one of the problems that we've had with Java Selenium tests in the past, that it's actually quite complicated to maintain them. We use Scalatest for unit tests, UI tests, and integration tests. So all of our testing is, or at least in some contexts, in some of our applications, it's pretty consistent, and it's pretty consistently written. Like I said, the Selenium DSL is integrated into Scala tests. We always put IDs on our elements because it's a good idea. Otherwise, you end up in XPATH hell. And basically, our integration tests work with heterogeneous actions in the same test. So we click on a button in the browser. We can check a call via a service. We can check something in the database. We can check something via SSH, that a process has been started on a remote machine via SSH. So this is something next. I'm going to pass on to what we were talking about with, I was talking to Bill last night about this. The problem with eventually is that you can eventually end up in eventually hell. I'm a big fan of eventually, but sometimes you end up with code like this. So what I would like is kind of an implicit eventually, so that every action that you do in its totality does an eventually. So this harks back to the Java application that we had at the beginning, except that it's wider. So I want the entire line to be retried, not just the text field. To override the text field method is reasonably easy, but I want the entire thing. So that includes the test at the end as well. Because if you could do that, then you pretty much remove the need for any eventually. You still need some blocks which are together, but most of the time you don't need it. So that's my that's what I want, Bill. I don't know if you worked out how to do it. Yeah. Yes. But yeah. Exactly. Well, okay, so the answer was that there is an implicit weight already in Selenium, and that's true, but it doesn't get around the problem. Okay, so let's try and illustrate the problem here, just to explain it. Is that when I refresh the page, let's say I'm looking for this table to exist. So I'm doing a lookup on the table initially, so that this will succeed, but it won't have any data in. So actually what I want is for both to be part of the same block. I want the test to be part of the same block as well. So if I were to implicitly wait on text field, then it would get to here and it succeed, but it wouldn't retry the whole block. It would then fail the test because bar wasn't bar. The value wasn't bar. Why is that the same? I don't know. Okay, so the second thing is slowing down. Now the problem with the problem with the Selenium tests, I shall illustrate it again. Why is that aborted? Okay, we'll do this one. So is everyone following what this test is doing? Because I can't. It's too quick. So I would like, maybe the implicitly wait will help there as well. Maybe you should have a mechanism for doing that. But the problem is that when you're running a test, you have the test here, and you have Selenium going here. It's very hard to follow what's going on. So I'd like to slow it down a little bit so that I can see what's going on and see what's happening. Those are my two things I would like. Okay, so back to... Me again. Follow. You need to follow. You need to read. You need to use. And you need to buy. Any more questions?
You said that you found that placing IDs on all of the elements is a good idea.
Yeah.
You know, a lot of our front-end developers would say that it's not because, you know, probably if you're developing some components and you want to put two of the component on the same page, or you're trying to, you know, move some piece of code and the IDs are starting to clash and your page is just not valid anymore. So they're using classes, even if it's unique, because when they will have two of these elements, they would have a possibility to, you know, the page at least would be valid. Yeah, that's just the idea. And the question...
Sorry, yes, you're right that it sometimes happens like that, but the question is, how do you know the difference between those two elements? How does the person that's using the Selenium
there should be some additional classes like specifying these components. Probably.
But you can do XPATH. You can do XPATH. You can do CSS, selector lookups, and what have you. So it doesn't always need to be IDs, but something to be able to identify that particular element.
Okay. And the other question, that there is a Selenium cloud or something like Selenium
grid,
right? Is it possible, you know, not to run a test on your local machine, but in the cloud for, using this configuration?
The DSL doesn't say anything about. It's just. I mean, the grid is all set up. It's all configuration anyway. So, but it's got nothing to do with that.
So the Selenium DSL is very good as a DSL, but it's also very low level in terms of testing because it's just pointing to some individual elements to do some action which might have like a business meaning. So how often do you refactor those bits and pieces into meaningful actions which you can reuse in other tests?
You mean like login?
For example.
Okay, quite often.
Okay.
So one of the advantages of having it in Scala, as opposed to, I've heard people using Excel and things like this, is that you can refactor that little part into thing and say, okay, we'll do a login as.
So your real library consists of lots of small actions, I guess,
yes.
And your tests are layered on top of that.
Yes.
Okay.
Lots of small methods rather than lots of small tests, but the methods can contain tests as well. That's a very good question. How do you do it normally? I don't know. How do you, if something comes along after you said, yes, this is 5, and, 3 seconds later it's no longer 5, it's 6. How do you do that? Is that what you're asking? Well, you can wait until it's in a quote steady state. It doesn't. There's nothing specific in the DSL for that. But if you have eventually there, if you see what I mean, and you judge that it's in a steady state. So what you could do is you could say, there are 10 items in this list, there's been 10 items in this list for the past 2 seconds, it's not going to do anything more, if that makes sense. Does that answer your question as well?
I would try just to answer.
Okay, sorry, Ron. Any other questions? Okay, thank you very much.